I just passed this paper up, and he has it, so you had to have it. What page did we say the cover, Unit 3 cover was? 29. So the Unit 3 cover should have page 29. So this is page 30. We are looking at radicals. Radical is the overall broad word for square roots and cube roots, fourth root, fifth root, sixth root. I could keep going. We're only going to cover square root and cube root. So that's the good news. Radical is the word to describe any type of root. Radical describes any type of root. Before we dive into the actual math behind it, let's talk about the overall concept in terms of a picture. Okay, so I was asking at the beginning of, or before we started, I said, do you remember how to find the area of a rectangle? Right? I said, do you remember how to find the area of a rectangle? Can you tell me what is the formula for the area of a rectangle? Y'all said it. Length times width. Right? You have a rectangle. You've got your length. You've got your width. If we want to know how much area the rectangle takes up, I would multiply the length times the width. What am I standing on?
Carpet. Rectangle.
I was really looking for the word rug.
Beige rug.
Rug. I'm standing on a rug.
Beige rug?
It is a carpet rug, right? When I hear carpet, I think like the floor is covered in carpet. When I hear rug, it makes me think it's just a certain area.
Okay, that's true.
Have you ever heard of it called an area rug?
Yeah.
It is. If you watch like HG.
When I was in a home store, it was called a rug area.
Rug area.
A home store rug area for rugs.
Area rug, because it is a rug that is going to cover a certain little area of the room. The reason I have it up here is because one, believe it or not, it actually helps with standing on these concrete floors. Just a little. But then two, I just like it because it's kind of like the central focus of the room. If I wanted to find how much area my rug is covering on the floor, I would measure the length and width, and I would multiply. Now, I wear a size 11 shoe. We'll say it's a 12, right? 11 and a half sometimes. 3, 4, 5 and a half. We'll say 5 to make it simple. All right, so 1, 2, 3, 4, 5, 6, 7, 8. So if this is a 5 by 8 rug, what is the area of space it covers? 40 square feet, right? Because I went by feet. We assumed my foot measures 12. It's actually 11 foot. So this is a 40 square foot area rug, right? Okay. Nope, let me leave that up there. What if I had the area of a square? What's the difference in a square and a rectangle?
All sides are equal.
Thank you. So instead of length and width, which implies two different sides, now we just have, we call it, technically it's an S. S and S for side. So what is the area of a square? S, what?
S times S.
S times S. How can I simplify that?
S times 4. S plus S. S times S times S plus S7.
S times S, do you recall from middle school, is S to the second power.
Oh, yes, I can forget that word.
S to the second power, okay? So, The area of a rectangle, length times width. If it's a square, still length times width, but the length and the width are actually the same number. So we could just say it's S squared. Okay, now where am I going with this? Going right here. I want you to imagine a 1x1 square. I'm going to draw it in circles.
Okay.
So here is a 1x1, right?
Yes.
There's one row, one column. So in fact, there's only one dot. I want you to find the area of this shape. What? 1.
Where's
Why is it 1?
right? 1 times 1 is 1.
1 times 1 is 1. Now let's do a... Where am I going with this? What comes after 1? 2 by
2.
2. All right, here we go.
4.
2 columns, 2 rows. What is the area of a 2 by 2? 4. Because how many dots are there? 4. You need to stay with me. Everybody stay with me. Now let's do a 3 by 3. 3 columns, 3 rows. What is the area of a 3 by 3? 9. Why? Because there's 9 dots. There's also 3 times 3 has an area of 9. All right, let's keep going. 4 by 4. So 4 columns. We have a 4 by 4. What is the area, stay with me y'all, of a 4 by 4? 16. Because if I was to count these dots, there would be 16 of them. What would be next?
5 by 5.
A 5 by 5.
5 by 5.
You're right next to the microphone, so can you please quit? We got a 5 by 5. What is the area of a 5 by 5?
25.
25. Because I've got 5 columns, 5 rows, so I would produce 25 dots. You with me? Or 25 squares. You could do it in squares. What do you notice I'm doing? What's the pattern? It's going up. What's going up by 1?
The number you multiply by, like.
So I started with a 1 by 1, then I went to a
2 by 2.
2 by 2, and a 3 by 3. What do you notice about these shapes?
Circles.
They're what? They're all squares. Except for the 1 by 1, which is just a dot. But in terms of a, like I said, you could turn this into squares. You could turn it into squares. The dots are just easier. So, do you see now the squares?
Yeah.
We've just generated the beginning of the list of perfect squares. They're 1, 4, 9, 16, 25. How would I get the next one? It would come from what dimensions of a square? It would come from a 6 by 6. This one was a 5 by 5. Next would be a 6 by 6, which produces the area of 36. Next would be a 7 by 7, which produces the area of 49. You are generating the list of perfect squares. If you can generate the list of perfect squares, you can actually go in reverse and tell me what is the, like if I said, what's the square root of 4? Square root is the undoing of it. The area of a square with 4 would come from a 2 by 2. If I said, what is the square root of 36? That would be the one out here. You would say to yourself, okay, what square would have an area of 36? It would come from a 6 by 6. Okay? Now, I've said all of that to guide you into what we're doing today so that you have a visual behind it, okay? Because everybody knows how to find the area of a rectangle. You all answered me that at the beginning. And everyone knows how to count. We just did it. So now what we're going to do is learn the new stuff. So let's talk about the vocab words associated with radicals, and then let's dive right into how to do this. First of all, we've got parts of a radical. There is the number in front, the number underneath, and then there is the entire thing. So the number in front is coefficient. I'll spell it right. Coefficient. That's the number in the very front. It is attached right here by multiplication. That's important, okay? It's attached to the radical by multiplication. The number under the radical is called radicand. And then there's a D on the end. It is not pronounced radicand. That's not how you say it. The D is silent. It's called radicand. Coefficient's the number in front. Radicand is the number underneath the square root or the radical. Radical refers to like the whole thing. This is the square root of 32. So this is your radical, the whole thing. This 5 square root 32 is our radical here, okay? There is an understood 2 here. In dots, can you please draw a 2 right here? This is understood, meaning you will never see the 2 written. We say square root because we are saying to ourselves, go back to that visual. Oh, I shouldn't have closed it. Oh well. Go back to that visual of the squares with the dots. We're saying what dimensions of a square have an area of, say, 36. And the answer would be, it's a 6 by 6. 6 by 6 produced an area of 36. Okay? So we're undoing the square. This is understood square root. Now the next line says, how do you pronounce it? There's a couple of different ways. Some people say 5 square root 32. I personally just say root. I just say root because that's understood to be square. If it's a cube root, you'll hear the word cube. If it's a 4th root, you'll hear the word 4. But if it's a square root, you might hear it as square root or you might hear it as just root. Okay, so we're going to write 5 square root 32. And then I'm going to put a slash to imply or 5 root 32. You might hear it either way. Okay? 5 square root 32. We'll put it in quotation marks or 5 root 32. Now, what we're doing here is we're learning how to take a radical and break it down when it's not pretty. What we did with the squares, those were pretty. Where do you have more room? Looks like at the top. Let's go back to the top then. So let's come up here to the top and let's make a list of perfect square. Actually, let's just go to the back. Go to the back of your paper because this is going to get crowded. Go to the back of your paper. paper. And I want you to recreate the drawing that we did earlier. So you've got one dot. That's a 1 by 1. It has an area of what, y'all?
1.
1. Then we would have 2 by 2. And it has an area of what, y'all?
4.
Oh.
Oh
That's a
my.
big old letter.
Oh.
It would have an area of 4, because it's a 2 by 2. Then we have a 3 by 3.
9.
Y'all quit. And it would have an area of
9.
what? 9. Let's go up to the next one. 4 by 4.
16.
16. 16.
Done.
And it has an area of
16.
16. Now, why did we do that? Because on the back of your paper, I want you to list the first 15 perfect squares. You're going all the way up to 15. So you got a 1 by 1, a 2 by 2, a 3 by 3, a 4 by 4, a 5 by 5. You're going all the way up to a 15 by 15. I want you to make that list of numbers right here. So what is the area of a 1 by 1?
1.
1, we already said that. What's the area of a 2 by 2?
4.
4. What's the area of a 3 by 3?
9.
What about a 4 by 4?
16.
What about a 5 by 5?
25.
Okay, I need you to keep going. This is why you have your...
No, 36.
Do this on the back.
Yes, we're doing this on the back.
Go on the side. Big
Yeah,
dog.
there's not enough room on the front. Don't forget I'm recording.
49.
Try that again, jerk.
I'm recording, guys. You're on the back of the paper. You're filling it in, the first 15 perfect squares.
What's this? Big hard.
So 7 by 7, y'all tell me the area.
49.
8 by 8,
64.
9 by 9,
81.
10 by 10,
100.
11 by 11,
121.
12 by 12,
144.
13 by 13,
169.
14 by 14,
196.
15 by 15.
225.
There you go.
Ah!
Now, here's one of the nice things about the EOC. You are going to have scratch paper. You get to write on the scratch paper whatever you want. Girls, stay with me. So one of the things that I would encourage you, and I will drill you for this when we get closer to May, is we're going to practice writing the first 15 perfect squares as you get closer to the EOC, so that when you take that EOC and you get your scratch paper, you can immediately make your list, because having your list is very helpful with what we're about to do. We've not even dove into the math yet, okay? So if you've already shut down on me, I need you to jump back in, because now we're going to actually learn the math behind it. So what's the point of what we're doing here? Well, sometimes radicals are not perfect. For instance, the square root of 32. Did you see 32 anywhere on your list as you created your perfect squares?
No.
No. That's because you cannot create a square with square, right? Where the sides are the same, with an area of 32. It's not possible. Now you can do it with an area of 36. That comes from a what? A 6 by 6. But an area of 32 is not possible. There's no number times itself that gives me 32. Okay? So enter simplifying radicals. A radical expression in its simplest form is when there is no perfect square left in the radicand, and then no radicals appear in the denominator of a fraction. We're not worried about that right now, but we are looking at when they're in the radicand. So look at this list. We have 4 steps to simplify a square root, and then we're going to come over here and we're going to do an example. Find a perfect square that divides into the radicand with no decimals. Has to divide into the radicand with no decimals. So let's come up with an example. Let's do 2 square root 40, right here. 2 root 40. We're going to break this down. Let's practice with our vocab words. What number is the coefficient?
2.
Very good. Remember, it is attached by multiplication, right? And then now, what number is the radicand? What number is the radicand? 40. 40 is our radicand. So now go to your list of perfect squares. We may have to flip over to the back. And I want you to find a number from your list of perfect squares that goes into 40 nicely. Find a number from your list of perfect squares that divides into 40 nicely.
What's the hard one? 5.
Bro, what are you talking
It has to be on your list of perfect squares.
Is it 5?
Has to be in your list of perfect squares.
about?
This is our list of perfect squares right here. This is our list. What number from that list divides into 40 nicely in that list? All right, let me help y'all. Go to your calculator. Do 40 divided by 169.
0.2366863905.
So did it divide nicely?
Absolutely
No.
If I have 40 pieces, can I divide them into 169 groups?
Oh.
No.
Oh,
Now can you wrap your mind around what we're doing?
yes.
Name another number that is absolutely not possible here
For 40?
for 40.
9.
What's another number? 15 is not possible.
64.
196 is not possible.
144.
144 is not possible.
100.
You can't take 40 pieces of something and cut them into 169 groups because this is bigger than 40.
49.
Okay, go to your calculator and do 40 divided by 49. If I only have 40 pieces, can I create 49 groups?
No, I'm saying that's the wrong one.
Oh.
You couldn't do it.
So we need to start on our list where our number falls. 40 falls right here, right? Which means everything higher than 40 is no-go.
No way.
You definitely can't take 40 pieces and break them into 49 groups. It's not possible. There's not enough. But can I take 40 pieces and break them into 36 groups? Nicely.
Yes.
Nicely?
Yeah.
No, I'd have some left over, wouldn't I?
Eat it.
Possibly.
What about 25 groups? I'm just dividing here. I'm saying, does 40 divided by 25 equal a nice number?
No.
No, it does not. This is where you need to know your multiplication facts. What number from this list
4.
will go into 40 nicely?
4. And 1.
1 is irrelevant. 1 works every number. Can I take 40 pieces and group it into one group?
Yeah.
Every time, right? So 1 is irrelevant. Can I take 40 pieces and cluster it into groups of 4? Yeah? How many would be in each?
10.
10.
Because 4 times 10 is
40.
45.
So 5 is not in the list.
He said
It has to
25.
be in the list. Guys, please remember you're sitting right next to the microphone, and I've got kids that are going to watch this because they're out. This is the list that we're going to look at. We look at where 40 falls, and we start working our way down the list. You should have some number sense to be able to eliminate some of these numbers. But let's say you're having a bad day and you're not really sure how to eliminate some numbers. Go to your calculator. Please do 40 divided by 36.
What is it?
You get a decimal, and that lets you know that you need to go to the next number. So you would do 40 divided by 25. Wake up, participate. And you get a decimal, that means keep going. Then you do 40 divided by 16. Decimal, keep going. Winner, winner, chicken dinner when you hit 40 divided by 4. All right. Wow, that was painful. So we've now figured it out. 4 will go into 40 nicely. Remember, you're pulling a perfect square from your list that will divide into the radicand. You're going to rewrite the radicand as a factor tree of the perfect square and the remaining factor. So here we go. 40 becomes the square root of 4 times the square root of 10. See the factor tree forming? 40 breaks into 4 times 10.
I see.
Right? Can you see? With me? All right. Now, you might think, well, what about the 2? The 2 comes down. You need to draw the arrow. The 2 is going to play a part in the end. Now, what is the square root of 4, y'all?
2.
Yeah? A square with an area of 4 comes from a 2 by 2. So the square root of 4 is 2. When you take the square root of it, you don't write the square root anymore. Okay? It is. It's very similar. And then bring down the square root of 10. Now I drew my arrow a little too far. Hold on. Right here. I didn't mean to draw that arrow that far. So we're going to put it right there. There's that 2. Now remember we said, how is the coefficient 2 attached? It's attached by what operation?
Oh, square root.
No, how?
Multiplication.
We said it's multiplication. So if I don't put this multiplication symbol right here, what does it look like I have in front of me? What number does it look like I have if I don't write my multiplication?
22.
Looks like 22, but it's not 22. It's 2 times 2 root 10.
2 times 6.
So because these are both numbers on the outside, you can multiply them and we get 4 root 10. Now here's the really cool thing about it. Go to your calculator and type the very first radical, the whole thing, 2 square root 40, and hit enter.
What is this way?
Square root, let me show. So the perfect square of 25 divides into 150 6 times. You've got to write it as a factor tree. This first one always needs to be your perfect square. This needs to be your perfect square every time because it will go one step further. What is the square root of 25? 5, because a square that's a 5 by 5 has an area of 25. So this becomes 5. What does this do? What did it do over there?
Stay the same.
It just comes down. So what is the square root of 150? In simplified form, it's 5 root 6.